Yeah, this is welcome to heat energy. Question, past question and answer in heat energy. What we are dealing with is what? Heat energy. Past question and answer in heat energy. You are welcome. If you have not subscribed to this channel, endeavor to subscribe. If you have subscribed, touch the like button and the word share to your friend. Thank you. Let's look at the question we have today. The question said, if a metal of mass 150 gram at 100 degree is dropped into 60 gram of water at 25 degree centigrade, contained in a calorimeter of mass 140 gram and specific heat capacity of calorimeter is 400 joule per kilogram per degree centigrade, 35 degree full stop. Calculate the specific heat capacity of the metal. In brackets, they give me specific heat capacity of water is 4190 joule per kilogram per degree Celsius. This is specific heat capacity of W, means water, is 4190 joule per kilogram per degree centigrade. Then we say solution. And I started by saying the quantity of heat. Q. What does Q stand for? Q represents quantity of heat lost or gained by any substance is given by Q equals to mass of the substance times specific capacity of the substance times change. This data means change in temperature of the substance. What did I say? Quantity of heat lost or gained by any substance, which represents by Q, is equal to mass of that substance, specific capacity of that substance, change in temperature of that substance. And we say where mx, m subscript x means mass of the substance, and C subscript x is what? Specific heat capacity of the substance. And the delta T subscript x is the what? Change in temperature of that what? Substance. Then you remember, and I said diametrical what? Explanation. Let me use diagram to what? Explain this more. Diagrammatic what? Explanation of the question. Look at it. What did they say here? They told me, come over here. They told me that what? A water, if a metal of mass 150 gram at 100 degrees centigrade, that means the metal is at what? 100 degrees centigrade, is dropped into 60 gram of water. Is dropped into 60 gram of water. And that water at what? 25 degrees centigrade. This 25 degrees centigrade was the temperature of water contained in a calorimeter of mass 140 gram. See, this water was inside the calorimeter. And for this water to be inside the calorimeter before the landing of what? Metal that is at 100 degrees centigrade, the water and the calorimeter must have the same temperature. Are you listening? The water was inside the calorimeter before the landing of what? The metal, the hot metal at 100 degrees centigrade. Then this water, which is in the calorimeter, was 25 degrees centigrade, the temperature of that water. Since the temperature of the water is 25, the temperature of the calorimeter in which the water is in is also going to be what? 25 degrees centigrade. That means the water and the calorimeter has the same temperature before the what? The landing of the what? Metal that at 100 degrees centigrade. What did I mean by that? Just like you pour water inside a bucket. You want to what? Bath. You pour water inside the bucket. The temperature of the bucket and the temperature of that water is the same. If the temperature of that water is 25, the temperature of the bucket is what? 25. Then now, you will now bring hot water to put inside that water so that it will be warm for you to what? Bath. It means that now, the water now coming in, before the hot water come in, the temperature of both the calorimeter and the water was what? 25. Then we'll come to this diagram. I said T1 is equal to 25 degrees centigrade. And what is that T1? The temperature of water and the temperature of calorimeter. They are inside the vessel. Look at the vessel here. Are you going to see now? The vessel contains what? The water and the calorimeter at what? 25 degrees centigrade. Then now, and now bring the meter. And what is the meter? Look at the meter here. The meter is what? T3 at what? 100 degrees centigrade. Look at the meter. Only him is here. Then I now bring this water and the meter and join here. And when you see it, what do you see here? You see meter, comma, water and the calorimeter inside this place. And what is their temperature? T2 equals to what? 35 degrees centigrade. And this T2 is what we call equilibrium steady temperature. This is the temperature in which what? The calorimeter and the water and the meter come to what? Stay. And what does it mean? You know that when I bring that meter at 100 degrees centigrade and put inside the calorimeter, who is going to gain and who is going to lose heat? And I see that what? The meter, which is at 100 degrees centigrade, we started losing heat. And what happened? The water in the calorimeter, we started gaining heat. And the calorimeter was also what? Started getting heat. The heat which what? The meter, the water and the calorimeter is going to gain will going to be what? Equal. And I say that who is going to gain heat? Calorimeter is going to gain heat. And the water that is inside the calorimeter is going to gain heat. Why? The calorimeter and the water was at 25 degrees centigrade. I think I explained. Then when the meter enters inside that water, the meter was at 100 degrees centigrade, the highest temperature. Then what will happen? They will start exchanging heat. They started exchanging. The meter will give them heat, while the water and calorimeter will give the what? The meter cold. At a point, they will come to what? Equilibrium temperature. And that equilibrium temperature, you see them, meter, water, and the calorimeter in one vessel. And that temperature of the vessel turned to what? T2 equals to what? 35 degrees centigrade. And that's what they give you. Look at the question they give me here. They say, comma, 35 degrees centigrade. This 35 degrees centigrade is a what? Steady temperature of both calorimeter, the meter, and the water. And look at it. That's what we call equilibrium temperature. And before the meter landed inside this place, it was at what? 100 degrees centigrade. Before the water and calorimeter feel the impact of meter, they were at what? 25 degrees centigrade. And I call them what? T1. Then now, looking at this diagram, the water we started what? Gaining heat. And I call it what? Heating process. The water and the calorimeter, we started gaining heat from the meter, which is at 100 degrees centigrade. I call it what? Heating process. And what do I write here? I say rise in temperature. What will happen? The water and the calorimeter, their temperature will start rising. Where does it rise to? It rises to what? 35 degrees centigrade. Then coming to meter. This meter was at 100 degrees centigrade. He started what? Falling in temperature. I call it fall in temperature. And what do we call the process? The process of falling in temperature is called what? Cooling process. This is what I did here. I said cooling what process? The meter undergo cooling. Why the what? The water and calorimeter undergo what? Heating process. They are gaining heat. Therefore, they are being heated. Are you what I'm saying? And at the point, both the meter, water, and the calorimeter come to an equilibrium temperature called T2, which is what? 35. And these people was at this stage before, and this person was at this stage before they come into one vessel. And they exchange their temperature, and they have the steady temperature, which we call 35 degrees centigrade. And this is what we call diagrammatical explanation of this. Then let us go into now calculation of it. Now we have no who lose the heat. We have no who gain the heat. We now see that what? Who lose the heat? The metal lost the heat, and who gained the heat? The what? Calorimeter gained the heat, and the water gained the heat. So these two persons gained the heat, while the what? The metal lost the heat. Heat lost by metal. Heat lost by metal. Q subscript M is equals to mass of the metal, specific capacity of the metal, times what? Change in temperature of the metal. Heat gained by calorimeter equals to QC equals to mass of calorimeter, specific capacity of calorimeter, change in temperature of calorimeter. Heat gained by water. QW equals to what? Mass of the water, specific capacity of the water, change in temperature of water. And now remember that heat lost by hot metal is equals to heat gained by calorimeter and the water. Who gained? Calorimeter and the water is the one that gained the heat, which the metal lost. We say heat lost by metal, hot metal, is equals to what? Heat gained by calorimeter plus the heat gained by what? Water. Are you getting what I'm saying now? Heat lost by hot metal is equals to heat gained by calorimeter and heat gained by what? Water. And we say Qm is the heat lost by metal is equals to heat gained by calorimeter plus heat gained by water. Then what does this mean? Removing this thing, I put mass of the what? Metal times specific capacity of the metal, change in temperature of the metal, and that gives me what? The heat what? Lost by metal. Then heat gained by calorimeter become mass of the what? The calorimeter times specific capacity of the calorimeter times change in temperature of calorimeter plus, look at the plus. This heat gained by water is equals to mass of the what? Water, specific heat capacity of the water, change in temperature of the water. Then I start. Then mass of the metal, look at the mass of the metal. And what they give me the mass of the metal to be? 150 gram is what they give me as the mass of the what? Metal. But we are talking about kilogram. Look at the unit of what? Unit of what? Specific capacity of calorimeter. It said 400 joule per kilogram per degree. That means everything have to be what? In what? Kilogram. Then what happened? I have to change, come over here. I have to change this 150 to what? Kilogram. And how did I do that? I divide 150 by 1000. And when I divide it by 1000, 150 gram by 1000 will give me what? 0.15 kilogram. The mass of the calorimeter. Look at the mass of the calorimeter. What did they say the mass of the calorimeter? The mass of metal was 150. Come over here. The mass of the metal was 150 gram. Then the mass of water is 60 gram. They said the mass of the water is 60 gram. And the mass of the calorimeter, what they give it to me? They give me mass of the calorimeter. Look at it. The mass of the calorimeter to be 140 gram. Then we come down here. We now say what? The mass of calorimeter, this MC, the mass of calorimeter, they said 140 gram. I have to change it to what? Kilogram. By dividing 140 by 1000. I divide 140 by 1000, it gives me 0.14 kilogram. Then I come here and I said, and the mass of water. What's the mass of water? Which we have already seen here is 60 gram. And I have to change it to what? Kilogram. By saying 60 gram divided by 1000, it gives me 0.06 kilogram, comma. Then specific heat capacity of calorimeter is given to me as what? 400. Are you getting what I'm saying? And the what? Specific heat capacity of calorimeter is given 400. Then what did they give me? They now said the specific capacity of metal is what they asked me as the question. That's why I say question mark. Specific capacity of metal is what? Question mark. They gave me specific capacity of water. Come over here. They give me specific capacity of water to be what? 4190 joule per kilogram. That's specific capacity of water. That's what they gave me over. Mass of the metal, hot metal, times specific heat capacity of the hot metal into T3, the temperature of the hot metal, minus the temperature of equilibrium temperature, that's steady temperature. And this is called initial minus final for what? Cooling process. This man undergo hot metal undergo cooling process. Therefore, we are under cooling process. The change in temperature is what? Initial temperature minus final temperature in what? Cooling process. Then we'll come to this. Equals to the mass of the calorimeter which gained the heat. You know that this is the man that lost the heat. Then mass of the calorimeter which gained the heat times specific capacity of the calorimeter which gained the heat into the temperature change. What's the temperature change? From initial temperature, from the final temperature, which is what? T2 minus T1. And we call this process what? Heating process. Heating process means that from your initial temperature was low, you will heat to a certain temperature. So to know the change in your temperature become your final temperature minus what? Initial temperature. And that's what we see here. Final temperature, which is what? Steady temperature of the what? The mixture minus the initial temperature of the what? The calorimeter. Here plus the mass of the water which also gain the heat, the mass of the water times physical capacity of the water which also gain the heat times the final temperature of water, because the water gain heat, we call it what? Heating process. Then the heating process means the water was at low temperature before and it get to final temperature, which we call now final temperature minus what? Initial temperature of the water. You remember that the initial temperature of the water and the initial temperature of what? Calorimeter are the same. Are you get what I'm saying? Now look at the T1, T1. Then now we begin to substitute the value. The mass of the metal was given to me as we converted it to kilogram, become what? 0.15 times the specific capacity of the metal which we are looking for. Then the change in temperature become what? 100 degrees centigrade of the metal when it was alone. Then in the mixture you got what? 35, which is steady temperature. This T2 is 35, the E3 is what? 100. Then here we come to the what? What we call calorimeter. The mass of the calorimeter was given to me as 0.14, which we have it as what? 140 gram. We now converted this to gram. We have 0.14, the mass of calorimeter, times specific capacity of the what? Calorimeter, which is given to me, look at it, 400 joule per kilogram per degree Celsius. Then we now see this, which is what? 400, the specific capacity of the what? Calorimeter, times the change in temperature of calorimeter, which is what? The final temperature, which is steady temperature, minus the initial temperature of the calorimeter, which is what? 25 degrees centigrade, plus the mass of the water, which also gain the heat, which is what? 0.06, times specific capacity of water, which is given to me, look at it, the specific capacity of water is what? 4190 joule per kilogram per degree centigrade. And that's what we put here, 4190. Then change in temperature, which is setting at 35, which is steady temperature, minus initial temperature of the water, which is what? 25 degrees centigrade. Then we will now come back here to say that this minus this will give me what? 64 times the specific capacity of the metal times this. I get what I'm saying now? Is equals to this mass is this and specific capacity is this. Then here 35 minus 25 will give me 10. Have you seen it? Times 10. Then plus this man 0.06 is this and 4190 is this. Look at it, times 35 minus 25 will give me 10. Then now coming over here, I take this 65 to multiply 0.5 and we'll have 0.5 times 65 times specific heat capacity of the metal equals to 0.14 times 400 times 10 will give me 560 plus, look at this plus, look at here, 0.06 times 4190 times 10 will give me 2514. Then this give me this and this give me this. Then summing them together, I will have that this times this will give me 9.75 times specific heat capacity of the metal equals to this plus this will give me 3074. Then now, making this subject of formula which they asked me to find, which I'm asked to find, making this what? Specific capacity of the metal subject of formula, we have specific heat capacity of the metal, divide through by what? 0, divide this place and this place through by what? 9.75. How would I have this man to be what? Cm, which is what? Specific capacity of the metal equals to what? 3074 divided by 9.75, because when this man divide this, it will cancel himself. Divide this, we have this. Then now, dividing this with your calculator, you will find out that what cm, which is basic capacity of the metal, is equals to 315.28. Then now, joule per kilogram per Kelvin. And this can be approximated. This answer can be approximated to 1 decimal places. This is 2 decimal places. This decimal, 2 decimal places. I can approximate it to 1 decimal places to say cm, which is basic capacity of the metal, is approximated to what? 315.3. This man is up to 5. So I round it up to the 1, and this man turned to 3. This man is up to 5, I round it to the 1. That's how I'll get the 3. And that will give me what? 315.3 joule per kilogram per what? Degree centigrade. And I put it as my what? Answer here. And this is my answer. And this one is what? Approximate.